Hello everyone. So now we have to evaluate this integral using spherical coordinate system. Okay, so here the function is 1 upon 1 plus x square plus y square plus z square, and the region is given by this. So step 1 is always we try to sketch the region. So if we see the limits here, so for z it is from 0 to 0 less than z less than or equal to square root of 1 minus x square minus y square. Okay. Similarly, the middle limit y is from 0 less than y less than or equal to square root 1 minus x square, and the last outer limit x is from 0 less than x less than or equal to 1. Okay, so that means it means z equal to 0. That means xy plane is one boundary, and the other boundary is, that implies the boundary if we see is z square is 1 minus x square minus y square, or we have a circle sphere x square plus y square plus z square equal to 1. So the lower boundary is the xy plane and the upper boundary is a sphere, a part of sphere. That means it is representing a hemisphere, and this would imply 0 less than or equal to y, and the lower limit is 0 and the upper limit is y square equal to 1 minus x square, or simply x square plus y square equal to 1. So that means the boundaries are sphere or circle. So let's try to plot them. So first we see on the xy plane. So on the xy plane, if we try to analyze, so we have x equal to 0 and x is equal to 1. And for y, the lower limit is y equal to 0. That means this line. And the upper limit is the part of a circle. So that means something like this with radius 1. Alright, so this is y is positive square root 1 minus x square. Okay, so in the base we have something like this, and on the top we have a spherical surface. So basically our region is something of this form. So this is my z, and we will just take the hemisphere, the quarter hemisphere of this kind. Okay, so if we try to imagine this, so we are just considering this part. All right, so our limit is actually this. This is our region for integration over here, and in the base we can see this is a semicircle. Okay, so if we try to imagine, so it is like a part of this circle, this part and this part, so this quarter part of the circle, and then we have to just flip it by 90 degree to trace this region. Okay, so it's like a coin. If we just move this coin like this, so it will trace the one part of the circle, one part of the sphere, right? So let's try to convert into the spherical coordinates. So we know spherical coordinates. So we know the spherical coordinate is x is equal to rho cos theta sin phi, y equal to rho sin theta sin phi, and z is equal to rho cos phi. Okay, so this determines this entire sphere, but now we have to be very choosy with the angles theta and phi. So from here, if we see our radius, we can see this. So in the base, this represents the angle theta. So we know that theta is from 0 less than theta less than or equal to pi by 2, as we can see from here. Radius is growing from for the sphere. This is a sphere. Z is equal to positive square root 1 minus x square minus y square. So this portion of the sphere has radius 1, right? So our rho is from 0 less than or equal to rho less than or equal to 1. All right, and now the turn is for the angle phi. So we can see that this coin, we have to just rotate it from 0 to pi by 2 degree. It's like a fan. So if we move this from 0 to pi by 2, we will trace this entire part of the sphere. Okay, so this angle from x axis to, from xy plane to z axis, so this is phi angle, and 0 less than phi less than or equal to pi by 2. So this will be our limit. So this will take care that the quarter portion is traced, and this phi will take care that the vertical region will be traced. Alright, and without fail the Jacobian in this case, the Jacobian J is rho square sin phi. Okay, and phi is between 0 to pi by 2, so it will be always positive, so not a problem. All right, so this is the base, this is the region where we are integrating. Now the next task is to convert everything. So we know that x square plus y square plus z square will be equal to rho square for the sphere. For any point in this whole solid sphere, it will be something like this. That means our function, which is 1 upon 1 plus x square plus y square plus z square, that will become 1 plus 1 by rho square. All right. Now, integrating the function, that means we are given 0 to 1, 0 to square root of 1 minus x square, 0 to square root of 1 minus x square minus y square f. That will become now triple integration, the Jacobian of the transformation, that is rho square sine phi, and the function is now 1 plus rho square. Okay, so the conversion will be this, and we can take any order. So we will take d theta, d phi, d rho, where theta we know it is from 0 to pi by 2, phi also we know it is from 0 to pi by 2, and rho we know it is from 0 to 1. Alright, so we have to evaluate this integral. So this becomes now, so this entire thing with respect to theta is constant, so it will be 0 to 1, 0 to pi by 2, rho square sine phi upon 1 plus rho square d phi, and we have integration 0 to pi by 2 d theta d rho. Alright, so this, if we evaluate the integral, this will be like integration theta 0 to pi by 2, and after applying the lower limit minus upper limit minus lower limit, so this will reduce to pi by 2 integration 0 to 1, 0 to pi by 2 rho square upon 1 plus rho square sine phi d phi d rho. Alright, so now we can see that this is again constant with respect to rho, so this will be pi by 2 integral 0 to 1, rho square upon 1 plus rho square is constant, integration 0 to pi by 2 sine phi d phi, and outer limit is d rho. Alright, and we know this will be equal to integral of sine phi is minus cos phi 0 to pi by 2, and if we apply the upper limit, if I take minus out, this will be cos pi by 2 minus cos 0, and that turns out to be 0 minus 1, so this is just simply 1. Okay, so we are reduced to pi by 2 integration 0 to 1 rho square upon 1 plus rho square d rho. Alright, so now the trick is this, I can write it as integration 0 to 1 rho square plus 1 minus 1 upon 1 plus rho square d rho. Alright, next is we will separate them. So this is pi by 2, and this integral will be now 0 to 1 rho square plus 1 upon rho square plus 1 d rho minus integral 0 to 1 1 upon 1 plus rho square d rho. Alright, so this gets cancelled, and this is just pi by 2, and this integral d rho will be rho from 0 to 1 minus this integral we know is tan inverse of rho from 0 to 1. Alright, so this is now pi by 2, 1 minus, this will be tan inverse of 1 minus tan inverse of 0, and we know that this is going to be pi by 2, pi by 4, and this is going to be 0. So final answer is 1 minus pi by 4. Alright, thank you.